In the vast indifferent silence of interstellar space, where stars whisper secrets across light years and the void swallows the echoes of ancient worlds, a solitary wanderer pierces our solar system's fragile boundary. It arrives not with fanfare, but with the cold precision of inevitability, hurtling at 137,000 miles per hour, its hyperbolic path a defiant arc against the gravitational tide of our sun. Discovered on July 1st, 2025 by the vigilant eyes of NASA's Atlas telescope in the Chilean Andes, this intruder bears the name 3I/ATLAS, the third confirmed interstellar object to grace our cosmic neighborhood. But as it streaks closer, revealing layers of anomaly that defy the textbooks of celestial mechanics, one question burns brighter than the solar corona itself. What if this isn't just a frozen relic from another star's cradle? What if it's something engineered, something alive with purpose, challenging us to confront the possibility that we are not alone? Hold your breath for, in the next frames of this unfolding drama, the blue glow of 3I/ATLAS emerges not as a quirk of nature, but as the 10th scream of defiance against the ordinary, a harbinger that could rewrite humanity's place in the stars. Imagine the scene. A pre-dawn hush blankets the observatory in Rio Hurtado, where the ATLAS system's automated gaze sweeps the southern skies, hunting for threats from the asteroid belt. On that fateful July morning, an anomaly blinks into existence on the monitors, a faint, fast-moving speck, trailing a whisper of coma like a ghost in the machine. Within hours, the minor planet center buzzes with confirmations. Pre-discovery images from the Zwicky Transient Facility at Palomar, dating back to June 14th, seal its fate. An eccentricity of 6.1, the highest ever recorded for such a visitor, propelling it on a trajectory unbound by our sun's embrace. Unlike the elliptical dances of solar system comets, 3I/ATLAS follows a near straight line, inbound from the direction of Sagittarius, near the Milky Way's bulging heart. Its speed relative to the Sun, 58 kilometers per second, surpasses even Oumuamua's 26 kilometers per second and Borsov's 32 kilometers per second. As if it were flung from the chaos of a distant galactic nursery, tumbling through the void for perhaps 10 billion years. From the outset, this object stirs unease among astronomers. Hubble's Wide Field Camera 3 captures it on July 21st, 277 million miles from Earth, revealing a teardrop-shaped cocoon of dust enveloping a nucleus estimated at 5 to 20 kilometers across, dwarfing Oumuamua's mere 100 meters by orders of magnitude. NASA's Jet Propulsion Laboratory crunches the numbers. A minimum mass of 33 billion tons, a behemoth that should have been spotted sooner, yet evaded detection until now. Ground-based telescopes at Lowell and Mauna Kea detect a marginal coma and a tail-like elongation just 3 arc-seconds long, confirming its cometary nature. Yet, as ESA's Planetary Defense Office mobilizes, the first whispers of irregularity emerge. Spectroscopic scans from the Canada-France-Hawaii telescope reveal an elevated nickel abundance, far higher relative to iron than in any cosmic ice ball, mirroring ratios in terrestrial alloys more than primordial mixtures. Is this a snapshot of exotic chemistry from a metal-rich parent star, or a fingerprint of artificial refinement? The data teases, but does not yet condemn. As August unfolds, the emotional weight of this encounter settles like cosmic dust on the shoulders of those who watch. For young astronomers in bustling control rooms at JPL or the European Southern Observatory, it's a rite of passage, a chance to touch the untouchable, to decode a fragment of the galaxy's hidden history. But for the broader human family, it's a mirror to our isolation. We've sent Voyager probes whispering into the dark, carrying golden records of our fragile world. Yet here comes an uninvited guest, bearing no salutation, only silence. Avi Loeb, the Harvard astrophysicist whose bold inquiries into Oumuamua ignited global debate, leans into the microphone during a late summer TEDx talk, his voice steady but laced with urgency. These interstellar objects are not just rocks, they are time capsules from alien skies. 3I/ATLAS, with its improbable size and speed, demands we ask, could it be more? His words ripple through social feeds, igniting forums where skeptics clash with dreamers, reminding us that science thrives not in certainty, but in the ache of the unknown. By September, as 3I/ATLAS hurtles inward, crossing Jupiter's orbit at 5.2 astronomical units, the anomalies begin to stack like storm clouds on the ecliptic. The first, its trajectory aligns within 5 degrees of the planetary plane, a razor-thin ribbon where Earth, Mars, and their siblings orbit in gravitational lockstep. The random probability? 1 in 500, per Loeb's preliminary calculations, a statistical whisper that could be coincidence or design. Traditional models predict interstellar wanderers should tumble in from random inclinations, scattered like buckshot from the galaxy's rim. Yet here it glides, almost as if attuned to our system's architecture, evading the debris fields that would shred a less precise path. Emotional undercurrents swell in the observatories. Veteran comet hunter Karen Meach, who helped unravel Oumuamua's enigmas, confides in a Nature interview. It's like receiving a letter from a forgotten relative, familiar in form, but the contents unsettle you. Ground teams at Gemini North in Hawaii composite images through red, green, and blue filters, revealing a reddish initial hue, likely dust scattering sunlight in long wavelengths, a veil over secrets yet to sublimate. Then comes the second anomaly, striking like a betrayal in the data streams from NASA's Transiting Exoplanet Survey Satellite, or TESS. Observations retroactively pinpoint cometary activity as early as May 7th, when 3I/ATLAS was a chilly 6.4 astronomical units from the Sun, farther than most solar system comets dare to stir. No outburst, no dramatic flare, just a steady whisper of gas and dust, as if the object anticipated the warmth, priming its volatiles with eerie prescience. TESS's wide-field stare, designed for exoplanet transits, catches this prelude, amplifying the intrigue. Why awaken so soon? In the quiet hours after data downlink, researchers pore over light curves, their faces illuminated by screens, hearts quickening at the implications. This isn't passive ice, it's responsive, almost watchful. Loeb, ever the provocateur, posts to his Medium blog, "Natural comets sleep until the sun's fire kisses them." 3I/ATLAS stirs in the shadows. Why? October dawns with a crescendo of tension as 3I/ATLAS slingshots past Mars on the 3rd, closing to within 18.6 million miles, close enough for ESA's ExoMars Trace Gas Orbiter and Mars Express to pivot their instruments in a ballet of opportunity. The Trace Gas Orbiter's Nomad spectrometer drinks in infrared signatures, detecting a massive carbon dioxide plume extending 300,000 kilometers, rivaling the Earth-Moon distance. Images beam back, a fuzzy silhouette against the rusty Martian horizon, its coma blooming like a nebula in fast forward. Yet here's the third twist. Material ejections, captured in fleeting glimpses, point not outward in chaotic sprays, but inward toward the solar center, defying the radial thrust of solar wind and radiation pressure. Every documented comet in our system exhibits the opposite, tails streaming sunward like banners in retreat. Spectroscopists at the Instituto de Astrofísica in Chile cross-check against Borisov's well-behaved outbursts. The discrepancy gnaws. It's as if the object is feeding on the sun's light rather than fleeing it, murmurs one postdoc, voice thick with the weight of paradigm strain. The emotional core of this saga pulses here, in the human element, the late-night collaborations bridging time zones, the shared awe in virtual war rooms. A young PhD candidate at Michigan State, Daryl Seligman, coordinates the International Observation Campaign, his inbox a torrent of raw spectra from JOX's Akari archive and Blue Origin's experimental scopes. "We're not just tracking a comet," he tells a CNN special, eyes alight with fervor. "We're eavesdropping on a conversation from another epoch." But beneath the excitement simmers doubt, a quiet fear that this visitor might upend not just models, but identities. If 3I/ATLAS is ordinary, it humbles us with the galaxy's indifference. If anomalous, It whispers of companionship in the cosmos, stirring long-buried yearnings for connection. As perihelion looms on October 29th, the object vanishes behind the solar disk from Earth's view, concealed since the 21st in a conjunction of cruel geometry. Yet space-based sentinels stand guard. Stereo A's QR-2 coronagraph from its Earth-leading orbit, SOHO's LASCO suite at the Sun-Earth L1 point, and the freshly deployed GOES 19's QR-1 instrument, launched in 2024 with unprecedented resolution. These platforms, born of solar storm vigilance, pivot to document the passage. Stereo A captures the approach, its wide-field lens framing the intruder against the corona's fiery lace. SOHO, the grizzled veteran orbiting since 1995, feeds continuous feeds, its C3 imager resolving the coma at 126 million miles from the sun, 1.356 astronomical units, a thermal gauntlet of 770 watts per square meter. GOES 19, NOAA's latest eye in the sky, drills down to fine-scale details, pixel by pixel, as 3I/ATLAS endures temperatures that should vaporize its crust. And then, the 4th anomaly erupts, non-gravitational acceleration. Trajectory refinements from the Minor Planet Center show deviations, subtle tugs pulling the object off its predicted hyperbolic curve, as if invisible hands adjust its course. For Oumuamua, outgassing explained a similar drift. Here, the forces exceed expectations by 13%, implying mass loss of over 10% near perihelion, per Eiffel science analyses. But no commensurate jets appear in SOHO's frames. Instead, a fifth peculiarity, extreme dehydration. Spectroscopy from Hubble's July pass pegs water content at a scant 4%, versus the 80 to 90% in Oort cloud natives. This parched wanderer, baked by eons of cosmic rays, sports a radiation-hardened crust up to 20 meters thick, per JWST's mid-infrared gaze in August, a shell that should insulate, not accelerate. The 6th anomaly lands like a gut punch, the approach vector. Tracing 3I/ATLAS's inbound path aligns it with the celestial coordinates of the 1977 WOW signal, that enigmatic 72-second radio burst from Sagittarius, etched in SETI lore as a potential technosignature. Spanning 48 years, two events from the same spatial origin, probability infinitesimal, less than 1 in a million, as Loeb computes in his Archive preprint. The 7th, extreme polarization in scattered light observed by Lowell's Discovery Telescope, suggesting a surface smoother than cratered ice, perhaps metallic or machined. 8th, a brightness amplification defying models. From August's green-red hues to September's steady glow, it surges fivefold by October, outpacing Oort comets by factors unseen. But the 9th, the chromatic transition, builds the crescendo. August's Gemini composites show green-red dominance, bioluminescent whispers from cyanide and dicarbon fluorescing under solar UV. As perihelion nears, coronagraph data hints at a shift, longer wavelengths fading, shorter ones surging. Then emerging on November 3rd, Lowell's telescope snaps the first post-perihelion portrait, a compact blue beacon streaking against dawn twilight. Distinctly bluer than the sun, proclaimed Zhang and Badams in their preprint, the hue a shock of sapphire against expected crimson. Dust should redden comets near the sun, scattering blue light away, while red persists. Temperatures at 1.4 astronomical units demand infrared glow, 20 times cooler than the photosphere's 5,800 Kelvin. Yet here blue spectral bands dominate, implying emissions at stellar hot levels, or internal fires defying Wien's law. The reveal hits like thunder. This is anomaly number 10, per Loeb's updated framework, a measurable color shift from green bioluminescent emissions to intense blue radiation signatures. Multi-platform data, Stereo A's approach phases, SOHO's unblinking vigil, GOES 19 structural acuity, confirms the reversal. No natural precedent exists. Astrophysical orthodoxy predicts red-shifted profiles, particulate veils transmitting red, while blue scatters. But 3I/ATLAS inverts it, radiating short wavelengths that scream of thermal outputs exceeding solar baselines. For an object at this distance to glow blue, Loeb tells Reuters, voice edged with restrained awe, suggests active thermal management, energy generation within, surpassing passive absorption. The implications cascade. If confirmed, we're witnessing engineering orders beyond human grasp, a system sustaining 5,800 plus Kelvin amid coronal fury. November 5th brings the 11th layer, though unnumbered in formal tallies. Post-perihelion images from British astrophotographers Buchner and Niebling reveal a complex tail structure, an anti-tail stretching 620,000 miles sunward, a smoking jet 1.86 million miles opposite, with outflow velocities hitting 0.248 miles per second. For natural ice, this implies 13% mass loss, a cataclysmic shedding. Yet no fragmentation scars the frame. The nucleus holds compact and tailless in R. Nave's Observatory's comparison to Comet Lemon's classic streamer. Loeb's blog pulses with the data. Did 3I/ATLAS just break up? Or is this propulsion, recoil from directed vents? The global community mobilizes, distributed radio arrays like the Allen telescope scan for structured signals. Excess infrared hunts propulsion plumes. Congressional probes push declassification of October 2. High-rise shots from Mars Reconnaissance Orbiter, promising thrice Hubble's resolution. The climax crests as December 19th nears. 3I/ATLAS's closest Earth approach at 1.8 astronomical units, 168 million miles, safe yet intimate. The most intensive campaign in history uncoils. JWST's NIR spec acquires direct infrared spectra, probing isotopic fingerprints of its birth star. Hubble resolves structural intricacies, hunting asymmetries that scream built. Dozens of facilities, ESO's VLT, JAXA's Subaru, even SpaceX's Starlink scopes repurposed for photometry, coordinate in real-time data shares. ESA's JUICE, en route to Ganymede, snags outbound glances near Jupiter. Models forecast intensified blue, luminosity spiking as CO or ammonia vents blue shift the coma. Loeb's plea echoes, maximum data now. The stakes? Enormous. Alien tech would eclipse our wildest engineering. Emotional peaks pierce the narrative. Tears in a Caltech seminar as spectra hint at nickel vapor's unprecedented, evoking NPR's Rohan Rahatgaonkar. It's billions of years old, yet teaching us our infancy. 3 frameworks vie for truth, each a revolution in waiting. First, unknown natural physics. Gaps in our models expose a crust of exotic ices, radiation altered to yield blue emitters, mandating textbook overhauls. Second, statistical edge. Low probability convergences birthing rarity, humbling our incomplete census. Third, technological origin, a manufactured emissary from extrasolar minds, answering Fermi's paradox with a probe that probes back. Combined odds, per Loeb's Monte Carlo sims, less than 1 in 10 quadrillion, akin to 15 lottery jackpots in a row. No prior visitor matches this tapestry. Oumuamua's silent thrust sans gas, Borisov's banalcy. 3I/ATLAS spans improbable to impossible, observed in real time by our apex arsenal. As the blue photons stream from stereo A, SOHO, GOES 19, they etch history's next chapter. This transit, under humanity's unified gaze, agencies, militaries, amateurs, transforms aerospace paradigms, fueling investments in Rubin Observatory's decade of hunts, interstellar protocols for the Rubin era deluge. Yet beyond equations, it stirs the soul. A reminder